About the algorithm behind stochastic gradient descent, let us first initialize all our parameters randomly. So parameters are given by theta. Then we're going to iterate through epochs, and at the start of each epoch, we're going to randomly shuffle all the examples in the dataset. After that, we're going to iterate through individual examples in the shuffled dataset and calculate the gradients of each of these examples. Then we're going to update the parameters to reduce the loss and continue repeating this for every single training example in the dataset, and that's a single epoch. And after that, we're going to repeat this for epochs. Now, let me also talk about some of the benefits of SGD over batch gradient descent. So of course, we have already covered that by computing singular data points, it's going to be much faster because we're going to have much more frequent rapid updates rather than having to wait for the calculation of the entire dataset to complete. It's also going to be much more memory efficient because we're only calculating gradients on a singular data point or a subset of data rather than massive data sets that can't even fit into memory. And the most interesting phenomenon is that the noise that SGD brings actually helps us to escape local minima and explore the lost landscape better. So sometimes you also want to minimize the noise. So that's why SGD sometimes is not just restricted to a singular data point, but we might use a mini batch instead to balance between the noise that helps us escape the minima and the noise that might be too much for gradient descent.